Okay, this video looks at the questions on Newton's third law. Okay, so the first question is, if the force on the carriage is equal and opposite to the force on the horse, how can the horse pull the carriage? Is the answer A, the horse cannot pull the carriage because the carriage pulls as hard on the horse as the horse pulls on the carriage? B, the carriage moves because the horse pulls slightly harder on the carriage? C, the horse pulls the carriage before it has time to react? D, the horse can pull the carriage only if the horse is heavier than the carriage? Or E, another explanation on what might that be? Now, you each put different various answers for this. Some of you chose quite a common one was C, that the horse does not have time to pull the carriage. It doesn't react sufficiently in time. That's not true. The forces have to be equal and opposite immediately. Okay, it's not to do with a time or a time delay or a reaction time. So that's a misconception. The explanation, the actual answer is E. It's another explanation altogether. The misleading part of this is that we assume the question is referring to the force pair between the carriage and the horse, which is equal and opposite. If the force pulls away with a force greater than the carriage can exert back, then the harness connecting the horse and the carriage would snap and the horse would bolt off and the carriage wouldn't go anywhere. So as long as they are connected, the forces are equal and opposite regardless of the speed. The force pair that you need to think about for this is the force along the floor that the horse exerts. Now the wheels have a low friction which enables the carriage to move smoothly. When the horse pushes onto the floor, he's putting an applied force and the floor is pushing back. So it's a different force pair, which is the reason why this statement does not apply to any of those four. The second question is a little more challenging, okay? So the key to this question is to break down how we answer the steps in physics. So I'm going to break this question right down. So a builder has a mass of 75 kilograms. So it helps by drawing a sketch. So if we imagine we have our cradle that our builder is standing on, and we know that it's connected via a pulley system which our man is pulling, and our man has a mass of 75 kilograms. Okay, so that's our system. Very simple sketch. Now, for our man, if I break this down into two parts, question A says explain why the net upward force on the man is the force exerted by the floor of the lift minus the weight of the man minus 650 newtons. So if I just consider for a second just the man. So our man is standing on our cradle, on our lift, and so he's standing on the floor. So our man is exerting a force on that, a force pair, but equally the lift is exerting a force on the man. So the forces acting on the man is there is an upward pull of 650 newtons. There is the reaction force from the cradle or the lift back onto the man. So there is another upward force, which we'll just label force R. And then the other force acting on the man is his weight, which is acting downwards, which is 75, that's his mass, multiplied by G. So that explains the first equation. Equation for B is if now we just consider the cradle, or the lift, again we have an upward force of 650 newtons acting on the whole cradle. We have the weight of the lift, or the cradle itself, which is 35 multiplied by G. And we have the weight of the man, okay, the reaction force of the man, acting downwards on the cradle. And that would obviously be through both feet, but just to simplify it. Again, we'll call that R, because these two forces must be equal and opposite. Now that ends up resulting with us in two simultaneous equations. So we have, for our man, he will have a force acting upwards on him. That is his mass multiplied by some acceleration, which is equal to 650, because that is one upward force, plus the upward force R, minus his weight. The cradle, on the other hand, will have a resultant force of 35, the weight of the cradle, and some acceleration, equal to 650 minus the downward force, this time, that the man exerts on the cradle, and minus the weight of the cradle. Because again, that is in the downward direction. So we end up with these two simultaneous equations. We can then add these two equations together to end up giving us 110A is equal to 1,300. The r's will cancel out, that's why we add the two simultaneous equations together, and we will get minus 110g. When we put the numbers in, that will give us a final answer into that of 110a is equal to 221 approximately, which we can rearrange to give us the value for the acceleration of a. So a is equal to 221 divided by 110, which is approximately 2 meters per second squared. Now we have this acceleration, we can put it straight back into either of these equations and rearrange them to give us r. So if I just choose this one as an example, we would have 250 plus the weight, which would be which works out to be about 735. Then we don't divide. My apologies. So what I've done is taken this. To get rid of it on this side. I've added it to move it over to there, and then we've got these two. So I minus 650, which will give us a value of r. And when we put that into a calculator, we will get a final answer of 235 newtons, which is the force R, and that is equal and opposite on both the man and the carriage.